Hello and welcome back to Principles of Accounting 2. I'm your host, Dr. B. Today we're going to be talking about lean manufacturing. The concept of being lean means to have less waste. The concept of being lean means to reduce cost. The concept of being lean means to be operating optimally. Operating optimally. That's the idea of lean manufacturing. We're producing finished goods with minimal waste, minimal downtime, minimal lead time. That's the idea of being lean. The idea of being lean is that we're being efficient. Efficient. So when we talk about lean manufacturing, we'll talk about it from the perception of being efficient. Efficient. Speaking of efficiency, we are in our very last session of this semester. We are in week 15. For those of you keeping track, there are 16 weeks in a semester. The 16th week is reserved for final exams. Week 15, just to kind of recap what's happening today, what will be due by this Sunday. We have chapter 27 homework, which is what we're discussing right now, lean manufacturing, and then we'll have chapter 28 discussion board. The final and then those two items will be due this Sunday. So chapter 27 homework, chapter 28 discussion, and any other remaining work. I will also, most importantly, note the final exam. The final exam needs to be taken by next Friday, not this coming, but the following Friday, May 4th. May 4th. May 4th, actually, I'm sorry, May 4th is, I guess it's on a Tuesday. Anyway, it needs to be done by May 4th, which is the final day for final exams. If you are graduating this semester, I have already contacted you by email because I received your name from the dean. I contacted you by email. It's like, congratulations, you're graduating. You need to take it by whatever day it is. I think it's the end of this week. So, having said that, please be very conscious. I will also note the final exam is currently open and available. So, if you do want to take it early, you're more than welcome to take it early. There's nothing wrong with that. What's covered on the final exam? It covers the second half of the semester. So everything after the midterm is covered on the final exam. Final exam is worth 20 points, 20% of your total grade. So please take your time. It's open book, open note. You can save it, close it, save, and return to it. It's not timed. It's pretty straightforward. A few of you have already taken it. The results are very positive. So most of you are doing very well on it. So again, it's open and available. So please feel free to take it whenever you're ready. Okay, so without further ado, let's jump into lean manufacturing. As I mentioned, lean manufacturing means to manufacture efficiently with minimal waste, minimal downtime, minimal deficiencies. The idea behind it is that we're reducing cost. We're being quicker in our responses. The majority of our processes and products are efficient. They're of high quality. Uh, when I think of lean manufacturing, I think about companies that have been manufacturing for a long time and they have the manufacturing principles down to the point where there's no waste. Some of these types of companies, we call them, in their processing, we call them just in time manufacturing, JIT, just in time. Just in time manufacturing means we get the product out to the customer at the time that they need it, at the time that they want it, at the time that they purchase it. Examples of these types of manufacturers would be Toyota, the automobile manufacturer. In fact, they invented just-in-time manufacturing. Toyota utilizes just-in-time manufacturing. Um, Tesla uses just-in-time manufacturing. Nike uses just-in-time manufacturing. There's a couple of other manufacturers out there that represent just-in-time manufacturing. If you think of like a special order type company or a manufacturer that specializes in what they do, they're typically just-in-time manufacturers that they get it to the customer at the time of the order. That's the idea behind just-in-time manufacturing. That's what lean manufacturing really is. It minimizes downtime, minimizes waste, high quality, high efficiency. That's the idea behind just-in-time. These type of manufacturers and non-manufacturers use what they call lean principles. We reduce cost, we increase quality, we reduce downtime, we reduce waste. That is the idea of being lean. Uh, when a company is lean, we reduce the inventory that we carry. What that means is my inventory is not just sitting on a shelf, not being utilized. I sell it quickly. I'm reducing what we call a lead time. A lead time is the time it takes to manufacture it, the entire time, the entire time. Okay, and we'll talk about it in a little bit more detail. Reduced setup times in the assembly process. Uh, our employees are cross-trained. They're more involved. We have zero defects. We emphasize supply chain. These are all concepts of being lean. Being lean. Uh, it's different than traditional manufacturing. So if you think about it from an automobile manufacturer perspective, Tesla uses lean manufacturing. Okay, they have the process down. There's very little waste. There's very little defects. Their employees are cross-trained, little startup time, little lead time, and they have low inventory, and they utilize supply chain. Traditional manufacturer, an example in the same industry would be Chevrolet or General Motors. That automobile manufacturing company, they have a lot of inventory. There's some uncertainty. They have a lot of the same styles. Um, there's a few defects, but they don't care. It's just a bulk manufacturer. And that's pretty typical. And so that's really the difference between a lean manufacturer and a traditional manufacturer. So in lean, we reduce waste and try to make things more efficient. We identify problems and try to solve them. Uh, a traditional manufacturer, it's kind of the opposite. They have more waste. They have more issues. When it comes to inventory, the lean manufacturer utilizes their inventory efficiently. What does that mean? Well, they don't have a lot of finished goods sitting on the shelf. Most of their inventory is tied up in raw materials and work in process. And in lean manufacturing, there's very little in terms of finished goods sitting on the shelf because they sell through. It's a sell-through process. What that means is that they quickly sell their products for just in time to be delivered to the customer. And so, from that perspective, there's not a whole lot sitting in finished goods. When it comes to a traditional manufacturer, they have a lot of finished goods sitting in inventory, and we see that it's very streamlined in terms of lean manufacturing. They use an example of a river. If you think of a river and the way that the river flows, the rocks represent problems. The tides represent swiftness, and we know that in rivers there can be obstacles. That's what the book likes that example. It's an interesting example. Earlier I mentioned this term called lead time. Sometimes we call it throughput. It's the time measured from start to finish and in between starting and finishing. Uh, Lead time represents how long it takes to manufacture a product. I'm sorry, this is very blurry. This image represents the total time it takes from start to finish. From the time raw materials enter work in process to the time the finished good is transferred to inventory. That total time we call lead time. There are two components of lead time. Two components of lead time. This part's very important, okay? There are two components of lead time. One is called value added lead time, and the other is called non-value added lead time. Value added lead time represents time that I am physically altering the product. Value added lead time is time that I'm physically altering the product. An example of value added lead time is drilling holes into a piece of wood in the assembly process. Another example of value added lead time is staining the piece of wood in the manufacturing process. Physically altering the product. That's value added. Okay? The other classification of lead time is called non-value added lead time. This is the time the product takes when it's waiting. Nothing's happening. For example, I have some stuff, I'm sorry, not stuff. I have some work in process inventory in the cutting department waiting to be moved to the assembly department. That wait time where the inventory is just sitting there, that is non-value added. Or it could be the time it takes to move the inventory from the assembly department, from the cutting department to the assembly department. The time it takes to move it on the pallet jack, to move it from one place to another, that's also non-value added. It's just kind of sitting there, right? So that's the idea behind it. Value added, I'm physically touching the product. I'm physically doing things to it. I'm adding value to it. And non-value added is time when the inventory just kind of sits there and does nothing, waiting to be moved from one step to another. So take a look at this nice picture here. We can see the difference between value added and non-value added as the product moves through the lead time from start to finish. Okay. Non-value added, we see raw materials and moving it from raw materials to the first department, which is drilling. As it sits in raw materials and is being moved from raw materials to the first work in process department, that is non-value added time. I'm not adding value to the product by simply letting it sit there and moving it around. That's non-value added. When I'm adding value to the product, I'm doing something to it. We can see in work in process in the drilling department, I'm adding value to the product. Then after I'm done doing that and it sits there for a while, when it's sitting there, it's non-value time. And when I'm moving it from one place to another, it's non-value time. But when I'm doing something to it, like in the packaging department, also part of work in process, as you know, I'm adding value when I'm packaging it. So we can see there are certain steps of the process, of the manufacturing process, that are non-value added time and value added time. So let's talk about how do we compute it. How do we compute it? Okay. We compute value added time through ratios. Okay. Oh, ratios. I know. I can hear you already. You're like, oh, Dr. B, you've given us so many ratios throughout the past 15 weeks. Yeah, you're right. I have. So here's another. The, now, just remember what lean manufacturing is all about. We want to reduce time, reduce idle time, okay? Make things more efficient. So in order to assess our value added time, we do it through ratios. To compute the value added ratio, we take the value added lead time divided by total lead time. And this tells us how well I'm utilizing my time, right, so to speak. So here we go. We have a total lead time of 125 minutes. All right. 125 minutes from start to finish, from raw materials to finished goods. 125 minutes. Okay. The ones highlighted, machining, assembling, and packaging, that is my value added lead time. Machining, assembling, and packaging. I'm adding value to the product by machining, assembling, and packaging. We also know these as work in process departments. Non-value lead time means I'm not adding value to the product. I'm not adding value to the product when the product is just simply sitting there waiting to be transported or is being transported from one department to another. So, I had said that the formula is value added lead time divided by total lead time. So let's take a look. Value added lead time is any time that is being used touching or processing, I should say, processing the product. So machining, it's value added. Assembly, that's value added. Packaging, that's value added. So I got 35 minutes plus 20 minutes plus 10 minutes. So let's see, 35, 55, 65 minutes. So if I take my calculator, I'm going to grab it, hold on, grab my calculator. I got my calculator here. I'm going to take my 65 minutes, and I'm going to divide that by 125 minutes to get 0.52. 0.52 is my ratio, also known as 52%. So 52%, I added my value added lead times together divided by the total lead time to get the 52%, 0.52. We can see that a lower ratio means that we have a poor manufacturing process. In other words, we're wasting time. So if 0.52 is okay, it's not great, but it's also not terrible. Terrible would be like 30%. Okay, that's bad. It's really bad. 50%, it's not great, but it's also not terrible. 52% is okay. The higher the ratio, the better, right? The idea behind this is that we want to have minimum non-value added lead time. We want to minimize that time where it's just sitting there or being transported because we're not adding value. The more we're adding value, the better, right? So that's the idea behind lead time. In lean manufacturing, we want to reduce our non-value added time. So that's the whole concept behind lead time. Now let's talk about another concept called setup time. Setup time is the amount of time it takes to set up the operation, okay, to set up the process, to set up the machines, to create a batch of inventory. That leads me to our next term called batch size. Batch size is amount of a product that we can produce after a setup. The amount of a product we can produce after a setup is called a batch size. Okay. A batch. A batch is a term that we use that represents an amount of inventory we can produce after a setup. A batch. Okay. A batch size is the quantity. The idea behind this is that after I set up my assembly line, I can produce a set amount of inventory. And that's what this represents. Large batch sizes are good, okay, because that means minimum setup. If I produce a large amount, that means I have less number of setups. However, the bad thing about large batch sizes is that means that I'll have an increase in inventory and lead time. Remember, the first principle is to reduce lead time, not to add to it. And in lean manufacturing, we also don't want a whole lot of inventory. So the goal here is to reduce setup times. Long setup times result in large batch sizes that result in large inventory and longer lead times. All of those things are bad. And when it comes to lean manufacturing, we want to reduce these four things. So let's look at it from an example. This is a service business example, okay? But you can apply it to manufacturing. We have a group of friends, 10 friends. They want to purchase tickets to a show, okay? And they're all traveling together. They all want to sit together. So they want a group of 10 tickets to the show. So there's two ways that the group of friends can buy their tickets. They can either go one at a time at the ticket counter and line up, or they can buy all 10 tickets at the same time. Okay? So if we look at this from that perspective, you got a group of friends. They either buy it one at a time, which is shown here on the left, or on the right side, one friend goes to the ticket counter and buys all 10. Let's take a look at what happens to the wait time. So we can calculate this thing called a batch wait time. In other words, how long it takes to run a batch. To calculate that, we take the value added time that we learned about earlier times the batch size minus 1. If I got 10 friends, that's my batch size. It takes approximately 1 minute to purchase one ticket. So remember, I got 10 friends. So 1 minute is the value added time. Multiply that by my batch size, 10 friends minus 1 equals 9 total minutes. That's my wait time. Take 9 minutes a long time, okay? So 9 minutes total batch wait time. Now if I compute my value-added ratio, 1 minute value-added time divided by 10 total minutes gives me 10%. Remember, earlier we said the lower the value-added ratio, the worse it is. So the idea behind lean manufacturing is that we want to reduce wait times. We want to reduce setup times. So in order to do that, we would prioritize and we would improve our setup to get the flow to be more efficient, to reduce wait time. So in our example, it would make more sense for our one friend to buy all 10 tickets at the same time. Going back to our other example, or let's say a new example. It's a new example. We've got a new example. Okay. Automobile manufacturing. This company produces engine starters, which is a component to get the engine to start. Of course it is, right? All right, so this engine starting company, they produce engine starters. Here is their lead time. We got non-value added time, we got value added time, and we have a batch size. Okay, so here's how it looks. My value added time, I got machining, assembling, and testing. That's value added time. So I got my calculator, 7 minutes plus 9 minutes plus 8 minutes equals 24 minutes of value added time. It takes the total lead time, which includes the value added plus the non-value added time to get your total lead time, is 49 minutes. You can also see I have 25 minutes of non-value added lead time. So 49 total lead time minutes, 24 minutes of that is value added lead time. And I have a batch size of 40. So let's take a look. We've got 24 minutes of value added lead time, 25 minutes of non-value added lead time. Now, what is my total batch within wait time? So earlier we had said the formula for total batch within wait time is to take your value added time, in our example 24 minutes, times the batch size 40 minus 1, so 39 of course. 24 minutes times 39 is 936 minutes. Okay, 936 minutes. The value added ratio. The value added ratio tells us we take the value added lead time, 24 minutes, divided by total lead time. Okay. Total lead time is 985 minutes. How did we get 985 minutes of total lead time? Well, we have 24 minutes value added time. We have 25 minutes movable time. If you take your total lead time times total lead time 49 minutes times your batch size minus 985. We've got 985 minutes for total time. Yeah. So looking at my value added ratio, I have 24 minutes value added time divided by total lead time, 985 minutes. That gives me a ratio of 2.4%. That's that's not good. 2.4% is not good at all. That means it's very slow. Uh, so what does all this tell us? What does all this tell us? This tells me a couple of things. We need to reduce our setup time. And the reason why we need to reduce our setup time is because we have too much non-value added lead time. And what happens when we have too much of that is we have accumulated inventory. And that's also not good. So what needs to happen here is we need to reduce our setups. That will reduce our batch size. We need to move our streamlined activities closer to reduce overall transportation time. So, in other words, in my process, in my assembly line, if I move machining, assembling, and testing physically closer together, it will reduce my total lead time. Which leads us into the next topic called product-oriented layout. Think of like a physical space, okay? Think of like an assembly line. You have your raw materials over here in the yard. Then you have your work in process departments. Assembling, we have drilling, assembling, testing, blah, 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 packaging, and then becomes a finished good. If you think about that physical flow, the physical flow as the product moves through the process. The idea behind it is we want to be efficient to reduce lead time, to reduce inventory, to reduce. You got one. Yeah, I'm getting to you. One way we can reduce all these things is to be efficient in our product-oriented layout. It's how we organize our process, our manufacturing process around the product. It's like the physical flow, right? It's a way of shortening the time in between different departments and in between different stages in the working process. And you can do the same thing in a service business through a process we call process-oriented layout. It's just how the physical structure is flowed. And what happens when we do this? We reduce the time of moving materials between processes. We reduce the work in process inventory. We reduce our lead time. We reduce our production cost. All of those things in conjunction leads to a more lean manufacturing business. Remember, we're talking about lean manufacturing throughout this whole chapter and throughout this whole discussion. We're trying to reduce our inefficiencies, reduce our inventory, reduce our costs. That's what the word lean means, yeah? To be efficient. In most lean manufacturing businesses, we involve our employees in a couple of different ways. We involve our employees in decision making. We cross-train our employees to get them to be more efficient. Having cross-trained employees is very beneficial because I can use employees in different areas within the business, right? Um, when I was in the hotel business, and I don't know if I don't think I told you guys this story. So you all know that I was a hotel guy. I came from the hotel world before I got into teaching. I was a financial controller for the second largest hotel in New York State. In that business, I was primarily responsible for the accounting operations, of course. In addition to that, I was cross-trained in a lot of different areas. Uh, I knew how the front desk ran. So I worked a couple of night audit shifts. I knew how the bell stand worked, so I was a bellman. I knew how to tend bar. I was also a bartender. I knew how to wait tables. I knew how to work in banquets. I knew how to set up banquets for weddings. A lot of different areas I was trained in. Okay, what that did for the hotel is they were able to utilize me during my downtime in other areas, making the hotel more efficient. And that is the concept behind being able to be cross-trained. For those of you in a service business or any type of business for that matter, I strongly recommend that you reach out to your employer and you ask them to cross-train you. It never hurts to be trained in other parts of the business. It can only help you. Being cross-trained uh, adds value to you. Okay, understanding different parts of the business adds value to you. Okay, uh, if there's ever an employment opportunity that opens up in your place of employment other than what you're currently doing, if you're cross-trained, it adds value. It adds value to you and it adds value to the organization. Having a lot of cross-trained employees adds to a lean business, a lean manufacturing business, a lean service business. The idea behind being lean means to reduce waste, to reduce time, to reduce costs. That's why it's important that we have employees involved in each step. When we are manufacturing in a lean setting, we do this thing called pull manufacturing. Pull manufacturing means it's made to order as it's needed by the customer. Example of this is Tesla. An example of this is Toyota. An example of this is there's a couple of examples. There's not a whole lot of lean manufacturers out there. Think of a business that it's made to order. You call them up, say, hey, I'd like to order one of these, and they make it for you based off of your order. In manufacturing. So an example would be Tesla, an example would be Toyota, an example would be other companies that make it to order. They don't have it in inventory. They have to go make it. Okay. That's called pull manufacturing. They pull it through the manufacturing process. And it's, of course, very streamlined because there's they don't have to pay for inventory sitting, waiting to be sold. Uh, there's a lot less waste involved. That's why pole manufacturing is very popular. It reduces a lot of those costs. A lot of other businesses use this concept called push manufacturing. Push manufacturing means they push it through the process and they build inventory waiting for it to be sold. An example of that would be General Motors, Ford, um, pretty much any other manufacturer where you see a stockpile of inventory. They use push manufacturing. They push it through the process and wait for it to be sold. That is not very efficient because there's a lot of cost associated with letting things sit in inventory, waiting to be sold. The idea behind lean manufacturing is we try to be as efficient as possible. We want to reduce scrap, rework. Oh, rework is the worst. It's like, oh, I screwed it up the first time. I got to go do it again. Oh, that's the worst. Oh, you forgot to measure twice, and you only measured once, and then you made the cut to the wood. And all of a sudden, you have a missized door. I've been there. I've done that. Measure twice, cut once. Avoid rework. Avoid disruption in the production process. You don't want dissatisfied customers, and you sure do not want warranty claims. All of those things lead to higher costs, and they're a result of poor quality. So in lean manufacturing, we try to eliminate this thing called a defect. Defects are problems in the workmanship. I may have told you this before. I don't remember, so I'll say it again. Nike. Nike, the clothing manufacturer, the shoe manufacturer. Nike. You know Nike. They do uh, sports clothing, sportswear. Nike uses this uh, manufacturing process called Six Sigma. Six Sigma. That means with every 6 million that they manufacture, there might be one defect. Every 6 million, there might be one defect. That's pretty good. That's pretty good. Nike has found ways to reduce defects to almost zero through Six Sigma. Uh, the process was developed by Motorola. It's used most Motorola. Those of you who may remember Motorola, they started in telecommunications. They're still around. They still do make cell phones, but they mostly are in other telecommunications for business to business sales. It was developed by them. It's used by Nike. It's used by a couple of other manufacturers to reduce as much waste as humanly possible and to reduce the risk of error. The process takes defining, measuring, analyzing, improving, and controlling, which, as you remember, are the part of the management principles, right? Those principles, Nike and Motorola and other Six Sigma manufacturers brought that to a very streamlined process, which helps them to reduce defects. Along the lines of lean manufacturing, which, as you know, the objectives of lean manufacturing are to reduce cost, reduce waste, reduce lead time, and to be more efficient. Efficiency is a major part of supply chain management. Oh, supply chain management. You probably heard this concept a little bit more in the past 12 months than you probably ever have before. Supply chain. Supply chain is the idea of coordinating and controlling the flow of material, services, information, finances with suppliers, manufacturers, and customers. Supply chain. Right now, the United States has a serious supply chain management issue. We have for the past 50 years, but it's gotten substantially worse in the light of the pandemic. What has happened? We have the majority of manufacturers of um, of computer chips are made overseas. Okay, they're typically in China and other areas around the Indo-Pacific region. That is where the majority of raw earth minerals exist, is in China. China basically controls the raw earth mineral deposit for the world, and that is used to create computer chips. Well, the pandemic kind of threw a wrench into things because a lot of the laborers to get the raw earth minerals from the ground through process of mining, uh, there was some disruption, obviously, because people got sick from the virus. And what happened is it caused a global shortage of computer chips. And because the computer chips come from raw earth minerals deposits in China, it created a significant problem around the world. And that is the flow of materials, right? Supply chain. Uh, the raw earth minerals get mined from China. The manufacturing of the computer chips are in other countries, and then it makes its way to the United States or to other destinations, right? And so when there's a disruption like a pandemic that to the supply chain, it causes serious problems around the world. And that's what we've seen this past year. And so to mitigate that risk from ever happening again, the United States is looking to do their own rare earth mineral mining. So it's an interesting situation. And it's very interesting that we're talking about supply chain right now with that regard. That's how supply chain works. That's why having a global supply chain can be good, can be bad. uh, to increase communication, we have these things called electronic data interchanges. That's when you swipe your credit card at the point of sale. It uses electronic data interchange to communicate the credit card number between you, the bank, the processor, and the vendor. And that's what makes transactions happen. Radio frequency identification devices, also known as RFID. These are chips that are embedded into a lot of different things. Your cell phone, your other electronic devices, your computers, your smart lights, your smart devices. All of these things have RFID chips in them. They are used to track your device by radio waves. They monitor and communicate with the product to the manufacturer, to you, to the vendors. We also have something called enterprise resource planning, which is heavily used in the accounting world to track things like raw materials and work in process and finished goods. Our enterprise resource planning helps supply chain operators in order to get raw materials to manufacturers. In accounting, we try to also be lean, if you could believe that or not. So in manufacturing, the idea behind lean manufacturing is we reduce waste, lead time, reduce cost, be more efficient. That's the idea behind lean manufacturing. In accounting, we try to also be lean by reducing the number of transactions, simplifying the accounting system. Uh, those types of things help accounting to be more lean. So we're reducing the time it takes to enter transactions. We can do this through this thing called combined accounts, raw and in-process accounts. That's where you combine raw materials with work in process. Uh, and of course, another way to combine accounts is through this thing called conversion costs, which we talked about a few weeks ago. Talked about conversion costs. It's where we convert direct labor and direct materials into conversion costs as it's moving through the work in process components. Also in accounting, we'll try to be lean through non-financial performance measures like the balance scorecard, which we'll talk about in the next chapter. And we also use other measures that track the company's performance like customer service metrics, which we'll also talk about in the next chapter. We also have direct tracing of overhead. That's where we track our manufacturing overhead through indirect labor assigned to the manufacturing process. We look at fewer transactions in accounting to be more lean. We look at how our accounting system is designed. We look at how we enter materials from raw materials to work in process to finished goods and how they moves through the factory. We look at how we record those transactions, right? Oftentimes it becomes very complex. So what we do in accounting is we try to use computer systems like QuickBooks, like a smaller company might use QuickBooks. A small manufacturer might use another software called Fishbowl. What Fishbowl does is it tracks all of the costs for your inventory. It tracks the physical flow. It's pretty cool. I've used that one before. It's fun, actually. There's other softwares out there that are designed to help navigate the complexities. So in this process of lean accounting, we use what we call backflush accounting. It's where we simplify things to make it easier to transfer product costs to other departments instead of pulling them in through conversion costs. It's just another way to be more efficient. Earlier I mentioned this thing called process called combining accounts. We gave the example of raw materials and work in process in one account. What you could do, it's a little bit more complex, but it simplifies it because you're using less transactions. Direct labor classification becomes more simplified through that process because we take direct labor costs and indirect costs, combining them through conversion costs. And let's look at it through an example. You've seen this type of example before when we did talk about conversion costs earlier on. So here's an example. We have a metal manufacturer, or fabricator, sorry. We have a conversion cost budget of 2.4 million, and we plan to utilize 1,920 hours of production. Conversion costs rates are calculated by taking the total budgeted conversion cost divided by the planned hours of production. So 2.4 million divided by 1,920 hours is $1,250 per hour of conversion costs. It's very, very similar to what we learned about when we talked about manufacturing overhead and how we find the rates. That was several chapters back. And of course, you get real granular with it and get it down to the product. This one's called conversion cost to cover the cost of manufacturing. So we take manufacturing time per unit. Our example, 0.02 hours. That's like saying, 1.4 minutes, something like that. So 0.02 hours times $1,250 per unit. Yeah, per unit equals $25 per unit of conversion cost. A couple of examples of how we would combine transactions. This just kind of gives you that rundown. We're not going to get too deep into the woods, right? I just want to kind of show you what that looks like. We won't ask you to do that on the final exam. Earlier, I talked about non-financial performance measures. These are metrics that help the business to understand how efficient they're being in lean manufacturing. I gave the example of customer satisfaction. You can look at it in terms of hours being spent in the manufacturing process. They're terms that are not in terms of dollars, right? Lead time, value added ratio, setup time, number of production line stops, number of units scrapped, deviations from scheduled production, number of failed inspections. These are all examples of non-financial performance measures. Tells us how efficient we're being in the manufacturing process, or inefficient in some cases. Just about every business uses a combination of both financial and non-financial performance metrics. We call this KPIs, or key performance indicators. Every business uses key performance indicators to understand their overall performance. And this also helps the business to be more efficient in their day-to-day operations and long-term decision making. Tracking overhead is another way for businesses to be more lean in their manufacturing process. Salaries of maintenance personnel, salaries of production supervisors, indirect materials, things that we can trace indirectly to the manufacturing process. The more factory overhead we can trace, the more efficient the company's being in allocating costs, and thus the overall cost is reduced. And another way to have a lean manufacturing business is to analyze your activities by looking at quality, value-added activities, and processes. In terms of cost, as you know, is one of the biggest driving factors behind business and their efficiencies. The idea behind lean manufacturing is to reduce costs. In doing so, we incur this thing called cost of quality. The way I want you to think about cost of quality is when you think about the cost of a product, we look at products in terms of quality. Okay, quality meaning high quality versus low quality. We know that things that are typically low quality, there's usually a low cost associated with them. Things that are of high quality typically have a high cost associated with them. In order to maximize the cost of quality, we look at costs that can be prevented. An example that would be costs associated with engineering, with quality control inspections, vendor quality, training our employees, maintaining our equipment. We call these prevention costs. A prevention cost helps us to prevent additional cost to the product. It helps us to prevent defects. It helps us to prevent inefficiencies. That's why we call them prevention costs. We know that we're going to have higher maintenance costs for our machinery, higher training costs for our employees, higher vendor quality costs. These costs will be a little bit higher, but it will reduce the cost of defect or prevent the cost of defect. Other costs of quality include things like appraisal costs, it's the cost of inspecting and testing products. Internal failure costs, those are the worst kind of costs. When we screw something up, it includes the cost of scrap and rework, because you got to redo it right after you screw it up. The external failure costs include things like recalls and warranty work. Oh, you can think of a couple of examples of that, right? There's a couple more. The idea behind it is that we want to control the cost of quality. We want to enhance our prevention costs and our appraisal costs, and we want to avoid internal failure costs and external failure costs by ensuring that we are manufacturing a high quality product using lean manufacturing principles. The idea behind it is where you reduce defect, we increase quality. That's the whole concept behind cost of quality. We certainly don't want any type of internal or external failures, because what happens here is if we have recalls or warranty work or internal failures, it leads to loss of customer and this thing called loss of customer goodwill. Customer goodwill is kind of like customers buy into your brand, right? They trust your brand. They trust that your quality is good. And when there's a problem, you lose that trust in the brand, right? That's the idea behind that. We want to prevent that from happening. And here's a nice graphical representation of the relationship between the quality of costs and the goodwill. So, when we're looking at this type of information, there's a couple of charts that are visually appealing and help managers to identify and control costs in this manner. One of those is called a Pareto chart. This Pareto chart is a bar chart that helps us to identify the number of categories. And it's largest to smallest, left to right. The Pareto chart started in Japan, utilized by Toyota. This chart helped Toyota to streamline their operations, help them to reduce costs and become a lean manufacturer. And we can see this Pareto chart helped Toyota to reduce it through visual representation. You can show this type of chart to pretty much any employee, and it shows how adverse costs are affecting the business. I think it's kind of cool. Management is also interested in this thing called a cost of quality report. Shows the total activity costs for each classification, percent of total quality costs associated with each classification, and of course the percent of each quality. And here's an example of that. Just a nice visual representation. Don't worry, I'm not going to test you on that. So as we talked about when we talked about value added and non-value added, when we talked about value added time when we were talking about lead time, I mentioned that value added time with respect to lead time is any time that we are improving or modifying the product in the manufacturing process. Non-value is a time it's waiting and waiting and waiting and being moved around and not being improved upon, right? The same concept applies to our customers. Okay. Value added activities are activities that help us to meet our customers' needs. Non-value added activities are ones that detract from our customer needs, like mistakes, errors, omissions, process failures. These are all things you want to avoid. But you can attribute uh, costs associated with it, whether it's value added or non-value added. Uh, Positive versus negative, right? So by allocating the activity costs through that type of classification helps the organization to understand how we can reduce our total costs through manufacturing. And this is a nice summary of value added versus non-value added through an example. In this example, we can see that 26% of our time is value added, 74% of our time is non-value added. That's relatively problematic for most companies to have that type of ratio, right? So it's interesting. When we look at our processes in order to reduce efficiencies, we look at our business processes of procurement, product development, manufacturing, distribution, and sales order fulfillment. Procurement is when we are purchasing materials. The company is purchasing materials. Product development, research and development, where we are developing and producing a product. Manufacturing, the manufacturing process. Distribution, how do we get the product out to our customers? And sales order fulfillment, how are we selling our products? So here's how it works at the end of the stage, after we've manufactured it. The sales order comes in from our customer. We put it into our computer system. If the customer is buying it on account, we run their credit. We enter the sales order in. That sales order tells the warehouse to then go to the shelf to pick up that item. Put it into the truck. The truck then delivers it to the customer. That is the fulfillment process. So in that process, the business analyzes this type of information to help it be more lean, right? We look at how are we running credit checks? How are we entering it into the system? How's it being picked? How's it being shipped? By analyzing each of those activities, we can then understand where we can be more efficient. So as you would think, each of those items has an associated cost, an activity cost. And so here's an example. We have 10,000 sales orders. Each sales order is $8 per order. We have 14,400 in credit checks, 9,600 in computer system entries, 36,000 warehouse orders being picked, 20,000 in shipping costs, giving us a total sales order fulfillment process cost of $80,000. Based on this information, we can see that the majority of our cost is being spent in the warehouse, right, in terms of picking it from the warehouse. How might I try to reduce that cost? I can use robots. I can reorganize the warehouse to be more efficient. That's what this type of information helps us to do. Um, so yeah, it's interesting. It's an interesting concept. And we can, after we've implemented our improvements, how does that translate into cost savings? So we calculated it before our improvements, so 36,000 from the warehouse. I made some improvements to my warehouse. Now, after I made my improvements, so now I got that cost down to 23,400. That gives me a cost savings of 12,600. How do you calculate cost savings? You take your activity cost prior to improvement minus your activity cost after improvement to get the difference, which is the activity cost savings. All of these things together lead to lean manufacturing practice. Now, what about non-manufacturing businesses like banks, hospitals, hotels, insurance companies? We can apply the same principles uh, in terms of time measurement, uh, when it comes to value added and non-value added. And this is just an example of that. First contact with a customer, scheduling time, wait time for service, the actual service. We can see that through that analysis, we can look at value added versus non-value added from a non-manufacturing perspective. Do the same thing in a hotel business. So if you look at the amount of time it takes from the time that you first have contact with the guest up until the time the guest leaves the property, when they receive their bill. From that time lapse, you can actually go value added, non-value added with each point of contact with that guest to identify the efficiency of the time being used when we're talking with the guest. So just an interesting concept. And that, my friends, is the end of lean manufacturing. We will now take a short 5-minute break. We will return in 5 minutes at 6:20, and we will cover the last chapter, which is the balance scorecard and corporate social responsibility. Very straightforward chapter, very short chapter. So we're just going to have a nice discussion around it. It'll be quick and easy, and we'll be wrapped up by 7 o'clock. So please take a short 5-minute break, and we'll return.